Hello everyone, and welcome back to the boiler classes. My name is Ben Weekly, and this is the fourth session in a series of boiler operator training sessions for low pressure boilers. And this fourth session will pertain to steam boilers again, and it will pretty much concentrate on the steam system itself. So I have been, for those of you that have just tuned in, I have been a boiler operator for about 30 years and a boiler instructor for about 25 years. So I've seen a lot of boilers and a lot of people out in the industry, and it's been a hobby of mine to do boiler classes and rub elbows with the guys and gals that do the same thing that I've always done all my life. So it's a great occupation, and I sure appreciate all you people out there that do the good work. I want to tell a little story, and I guess if you've been following along on the classes, you know that I tell a little bit of a story at the beginning of each class. And this here story is about a guy that he was born around the middle of the 1800s, and he became a businessman in the later 1800s. And as a businessman, he heard about an invention that somebody had invented and patented over in England. And it piqued his interest, and so he jumped on a boat and he went to England and met this man that had this small invention. He called it a turbine engine. It had simply one moving part, one axle through the middle. It was just a small thing. He watched it operate and he thought, boy, if I could make this small thing way bigger, I could generate electricity with it a lot cheaper than the way we're doing it now in the United States with reciprocating engines. Electricity back then was very expensive because it was costly to produce because of the type of engines that were used. So he talked to this guy and he brought his patent. It was a very small sum at the time, but the guy wanted some money, so he sold his patent to this fella, and he sold all the drawings, and he packaged up the small turbine engine, and he brought it back to his shop in the United States to work on. He, along with some other people that he hired, enlarged this idea of a turbine engine and made it viable, and was able to produce quite a few of these big turbine engines, and was able to produce electric power cheaply, and lots of it, using steam engines to power a steam turbine. The guy's name, maybe you've guessed it by now, is George Westinghouse. Ring a bell? Lots of stuff that we deal with and purchase over the years has the name Westinghouse behind it. Well, so much for the history lesson today. I want to talk about the steam system on steam boilers. And after all, we got the boiler there to use the steam system. In other words, the water in the boiler goes up just so far in the boiler, and then as it boils, the rest of the boiler holds and contains the pressure of the steam. And from there, it is piped into different steam systems, and in a heating situation, it goes to heating radiators and heats rooms. Now, on the top of each steam boiler is what's called the main steam line. It comes up like this and almost immediately will make a turn that turn is not necessarily meant to avoid the sealing in the boiler room. It is there also as a means to allow expansion and contraction. So it's an expansion bend protecting the piping from fracturing. So we got the main steam line coming out, and then we always have a main steam stop valve. And the main steam stop valve usually are on larger boilers, medium to larger boilers, will be outside yoke and stem valves. And those are stop valves that are also gate valves. And when you use an outside yoke and stem valve, you turn the big handle, and as you open the valve stem appears from the valve, and when it's completely open, the valve stem is in the completely open position. You always use these main steam stop valves either in the fully closed position or in the fully open position, nothing in between. So the main steam stop valve is what enables you to shut off the boiler and cool things down and isolate it. Now, if you got more than one boiler, if you have more than one boiler in a plant and you got, say, 3 or 4, the main steam stop valve allows you to take that particular boiler out of service and work on it and then return it to service again. Now, the main steam stop valve is there. The steam goes beyond that, goes up into the main steam line, and then drops into what's called a header. The main steam header is usually just a big round tank, whatever size it needs to be. Some of them are 2 foot around, maybe 4, 5, 6 feet long or better. And off of that tank goes the steam lines that goes to the various parts of a building or a plant for use. So those steam risers come off of the header. Now you can isolate those with valves as well. So if you didn't want to, say, heat the gym, you could shut off that particular valve coming off the header, and then all the rest of the valves would operate and the rest of the building would have heat. Like I say, the main steam stop valve has an outside, what's called outside yoke and stem. So you might be in a boiler plant where the top of the boiler, where this main steam line comes out, it might be 25 or 30 feet up off the floor. So a main steam stop valve with an outside yoke and stem, it's quite easy to see whether it's open or closed. If there's no stem protruding out of the valve, it's closed. If the stem is out, it's open. Very simple. At a glance, an operator can tell what the position is because it's never halfway or anything like that. It's either closed or it's open. Now there's another valve called the non-return valve, and that's a secondary valve that's placed in the main steam line, and usually that is placed on larger boilers, and it enables the operator to cut in boilers, what they call cutting in or bringing the pressure up and joining the system with 3 or 4 other boilers. So it allows the operator to cut in the boiler online, or if something should shut down on that particular boiler and it loses pressure, the automatic non-return valve acts as a check valve and stops the flow of steam out of the header back toward that particular boiler. So I guess that's about it for those particular valves. So now, once everything is up and running, you got the steam goes past the main steam stop valve, it goes in, drops into the header, And the header can be pretty good sized chamber. It's sized according to what is needed. And off of that goes the main steam risers to the various parts of the building. Just keep in mind that steam will go through a steam line without being pumped. So there are situations where steam is very desirable. You don't need a pump to pump steam. It just automatically flows under pressure. Now, steam in a heating situation goes to steam radiators. And those steam radiators bring in the steam as needed with a valve, and the steam goes inside of that radiator, and it radiates and heats it warms up the room, and the thermostat will shut off the valve and it will close. So once the steam is used, then the steam drops back to water and returns in a form of condensate. Condensate is nothing more than water that's been boiled to steam, it's been treated with chemicals in the whole system, and then returns to the state of water again. Okay, years ago when they first started out, they would build a boiler and they'd bring a pipe out. And for heating a building, they'd take this large pipe and they would have pressures very, very low, maybe 1 psi. And the pipe would go up fairly high, say in the basement of the home, and then it would gradually taper down around and slowly return to the boiler. It's called a one-pipe system. It wasn't very efficient because they would take a pipe and they would go up to a radiator and the steam would go up there, and then the steam would return in the form of condensate and go and drain into the bottom of that pipe. And then that in turn, that condensate would flow around and come back to the boiler. Well, it was a lot of steam wasted, and there was no way to contain the steam up into the heating units. So a lot of the steam would be wasted there, would come out along with the condensate, and it was an undesirable, inefficient system. So the one thing that was invented was called a steam trap. You wanted to be able to contain the steam in the heating unit. And once it's used there, it turns to condensate, and then the steam trap would open and allow the condensate to go back to the boiler. So it was separated, the condensate was separated then from the steam. Much more efficient, a much better system. So the question I ask is, what do steam traps trap? What do steam traps trap? Well, let me ask you, what do mouse traps trap? Mice, right? Same thing with steam. That's why they call them steam trap. It traps the steam in the radiator. Now, these steam traps that are placed throughout the steam system come in various forms. And they not only get rid of condensate and trap the steam, but they also allow air to escape the system. So if you have a system that's fully closed and you add steam and you get that air, it would simply come up and pressurize against that air and not flow on through. So the steam traps also will allow air to escape. One of the most simple steam traps is called the thermodynamic trap. And this trap can be installed, it can be repaired and replaced quite easily without removing the trap itself. The top of this thermodynamic steam trap unscrews like this, and then you can see the thermodynamic disc that's in it, and that you can unscrew that and remove it. for service and replace it if something goes bad. So that's a thermodynamic steam trap. Very popular out there in smaller heating systems. Screws together like that. If the valve seat at the bottom becomes worn and leaks steam, a tool can be placed on that and smooth that out and put a new trap or a new disc inside of this, and you got it just like another brand new trap again. Very economical to repair. So one of the steam traps in the industry is called a thermodynamic steam trap. The next steam trap that I'm going to show you is called a thermostatic steam trap. This too can be placed in the steam system, and it can be repaired without being disassembled from the piping system. You simply unscrew the top of this, and you can see the bellows with the valve stem here that sits against the valve seat on the inside. The bellows heats and cools as the steam and condensate react against each other, and it will discharge steam, and then it will close once the condensate is out of the trap, and it traps the steam up into the heating units. This is called a thermostatic steam trap. There's another steam trap used out there in the industry. This is called a float thermostatic trap. It's a little bigger. You can see where the pipes go in and out, and you can repair these quite easily by taking the bolts off the front of these, and you can open this up. Now, once I open this up, you can see the float inside of this float thermostatic steam trap. So there it is, right there. And up here, if you notice, there is a thermodynamic disc, and that allows any built-up condensate, and it also allows air to escape the steam trap so it can operate correctly. So you have a big cast iron chamber that's piped into the system. If you need to repair this system, most cases you just buy this little unit right here and pull the old one off and put the new one on. Quite simple, isn't it? Anyway, that's a float thermostatic steam trap. There's one other steam trap that is used commonly in steam industry, and that's called an inverted bucket trap. Inverted bucket. On the internal parts of the steam trap on an inverted bucket, there is what looks like a cup upside down or a bucket upside down. And as the condensate and steam work against that bucket, it opens and closes a valve and allows the condensate to escape, and then it closes and allows the steam to be trapped into the unit. Now, one thing you will always see that's associated with steam traps is called a steam trap strainer system. Now this here strainer goes in the steam line, and as the steam approaches your steam trap, it filters the steam in case there's impurities, in case there's any type of slag or dirt or anything like that gets in there. And this little filter here filters out any kind of impurities in the steam before it gets to the steam trap. Otherwise, the orifices in the steam trap are very small, and material getting through there would plug the steam trap and render it unusable. So that's a steam trap strainer. If your steam trap is unusable, then it will fill through a process of condensing inside. The steam will continue to condense inside your heating unit, and it will start to fill up with condensate water. And once it begins to fill up, the effective use of that heating radiator becomes less and less. Eventually, it won't heat at all. So if you have a room in a building that has a steam radiator in it, and it feels a little warm, but it's really not doing the job, chances are it could be your steam trap that is not operating correctly, or the steam strainer needs to be cleaned out. Well, anything mechanical, as most of us know, can and probably will fail at some point. So the same thing happens with steam traps. We have to test them once in a while and make sure they're in good operation. There's a number of different ways out there, and the textbook that I've referred you to talks about the different ways that steam traps are tested. One has to do with temperature indicator crayons that give you an indication of a drop in temperature on one side of the trap versus the other. There are inline flow indicators also that you can visibly see if the condensate is passing through the steam trap. There are ultrasonic systems, so you can hear what's going on inside of the steam trap, give you an indication if it's working correctly. And then there's infrared and ultrasonic thermometers. Those different types of systems work better on different traps and different size traps. Well, when we talk about testing steam traps, if you're a new boiler operator or you've been operating steam boilers for a while, I gotta tell you, it's just not as easy as they explain in the book. Many big plants will have a department that services steam traps. They will have highly trained individuals that are experienced, and they will go around and test these steam traps and make sure that they're operating correctly. They may even have a written log on these. They may have preventative maintenance procedures so that based on the history of the failures, they will go out and they will change these steam traps out and rebuild them on a given schedule to keep everything working correctly. But I'll have to admit to you, it's just not as easy as it sounds. So that's, I guess, the essence of the steam system. The steam leaves the boiler, it goes through the main steam stop valve. Sometimes we'll go through the non-return valve if your boiler has that as well. It'll drop into a header and pressurize that. And then off of that header will be steam risers that go to the various departments in the building. And then from there it is used. In a heating situation, it goes into heating radiators. Now, one thing about a heating radiator, there are a lot of them out there that have automatic vents on them. So as the steam comes up to pressure and warms everything and pushes into the steam radiators, that little vent will open and allow the air out, the cooler air, and the minute the steam hits that vent, it closes the vent, and then you are in good working condition. That's about it for this session. One more time, make sure, if you haven't already, purchase this book, Low Pressure Boilers by the American Technical Publishers. And this particular book that goes with it, Low Pressure Boilers Study Guide by the American Technical Publishers. Go to their website and purchase these books and then read them chapter by chapter and follow the chapters with my video series. If you're in Minnesota and you've never had a license and you have no experience, the starter license is obtained by studying this book right here from American Technical Publishers, Safe Boiler Operation Fundamentals, Special Engineer's Guide for the state of Minnesota. So we'll be going on to session 5 next, and I would encourage you to get these books and read chapter 5 from one end to the other, do the study guide, and then come back and watch the video, session 5, and we'll all learn together. So once again, happy boiler operators to all of you out there. Thank you for watching.